So as Charles said, and as it says a couple places here, my name is Brian. I'm a member of the Stan development team, and I'm going to be talking about something we're working on over the past summer that we're calling Stan Playground, which we're hoping can kind of change the way that people try Stan for the first time, or if you're an educator and you're trying to teach Stan, you can use it. And so first I'm going to talk about who we is. So my name is Brian. I mostly work on the sort of compilation side of Stan, but I also work a bit on some of the Python packages. I'm a software engineer at the Flatiron Institute in New York, which is part of the Simons Foundation. Also in attendance is Jeff. You can raise your hand and wave. And then the third member of this collaboration was Jeremy Magland, who's a data scientist at the Flatiron Institute. And so this story started a few months ago. I was reading some blog posts by a man named George Stagg. If you're a big user of R, that may be a familiar name. He's worked a lot on some R packages and some stuff around that. And he had a blog post about using Fortran in a web browser, and I thought that was kind of interesting. Like I mentioned, I'm kind of very interested in compilers and that sort of thing. And so I thought, you know, if he can get Fortran to work, how hard could it be to get Stan C++ to work? And the answer is like not that bad. So I hard-coded the data into the transform data block. I picked a random model, and I did some hacking together, and I got this web page where you could do nothing other than click run, but it would actually run nuts in your web browser. This is using a technology called WebAssembly, which is a relatively new entry into sort of the world of how you can do things on the web. You may have heard that like the web runs on JavaScript. But now it doesn't have to. It has this other option where you can compile most existing languages to it. And so I thought this was cool enough that I talked to Jeff, and he sort of taught me some stuff about doing a bit more interactive web design. And I built what I've called the Stan Web Demo. So this is actually still a live site. You can go to it. And it basically is the Bernoulli coin flip model. You can pick how many times you flipped a coin, how many of them came up heads, click run, and it will run HMC in your browser. It should work on your phone as long as you have anything that's like reasonably up to date. And it'll give you just a plot of the posterior. You can look at the output, which is like the same as command Stan. And so this was pretty cool, and I posted about this on the forums a few months ago, and then a few people on the forums, then also at lunch one day, Jeremy said, you know, it'd be really cool if we could edit that Stan model. Because this would be nice if you were sort of like building a notebook, or if you had a case study and you had a fixed model, but for a lot of other purposes, it'd be nice to edit the model. So he asked, you know, how hard would that be? And I explained, like, you know, trying to fit a whole compiler into the browser would probably be kind of messy and all these other things. And he said, well, what if we just had a server for that part and then everything else ran in your browser? And I said, well, that would probably work. And kind of as a spoiler, it does. So I'm going to go to the next slide. It occurred to me while I was sitting here that maybe having 100 people try to load the website all at the same time during the first ever public demo could go badly. So I'm going to ask that until I show you how to use it, no one actually open this yet. And then I'll leave it up like before the break, and you can try it out. Does that sound good? So the result of that collaboration between Jeremy, Jeff, and I, and him saying, what if we just had this one piece run on a server, is Stan Playground. And so for the rest of the talk, I'm going to kind of do a live demo in the browser of all the stuff it can do. So let's hope this goes well. How is this for size? In like the back row, thumbs up? OK. So first thing you do when you open it up is you'll get this nice blank page. And it will have a few different panels. So it might look kind of familiar to something like RStudio or like, you know, one of these sort of panel-based editors. And the instructions that are up here at the top is you can either start editing the Stan model, or you can click on example on the side. So I'm going to use this nice linear regression example. So this is just a very simple, there's one predictor, one outcome, and the data in this case is just, the x is 1 to 10, and y is, pretty clearly just that plus with a little bit of a slope and a little bit of noise. But the first thing about this is that it is editable, so I can, say something like, hi, StanCon. It also is Stan syntax aware, so it has Stan syntax highlighting. It also will give you Stan error messages. So if I do something like, I put a bracket that is mismatched, it highlights it in red, and it gives you a red underline, and it says, hey, this is wrong here. You can also click up here to get a more sort of familiar explanation from the compiler of, hey, you made an error. It also has support for like Stan's built-in warnings in the editor and stuff like that. And you can also use the Stan auto formatter if you want to format your code. And so this is like a sort of a Stan IDE in a lot of ways. It has a lot of sort of built-in support for using Stan for either existing users or new users. The data blocks, so these editors are all based on the same thing that uses VS Code, so all your standard keyboard shortcuts will work, and they should feel familiar if you've used those sorts of things before. So once you've sort of edited your model and you're sort of happy with it, you can then sort of click compile. So we give you a couple places to do this. And so like I said, this is the one part that will use a server. So we provide a server, but there's also the ability to customize. And so while this will take probably 20 seconds, so I'll show you in the meantime. Up here, you can click on this panel, and it gives you the choice. So we provide a public server that we're hosting at Flatiron. It's reasonably powerful, as long as everyone in the room here didn't try it at the same time. But you also have the ability, so in our GitHub repository, all of the code for the front end and back end is open source. And we provide instructions if you want to run your own server, either because you want to test something out, or if like you're running a class one day and it would be really, really bad for you if the server was down, you have the option to run it yourself. So you might have to install something, but your users wouldn't in that case still, or your students. So that has compiled, and now we have the option to sort of pick some parameters. So these are just the similar defaults to Stan, 1,000 sampling, 1,000 warm-up. And if I click run, it will probably finish before you can even view the nice progress bar animation. OK, so it took a little bit of time. So this is something that I still find kind of surprising about this, is how actually little you have to give up in terms of runtime to run things in the browser. The biggest thing you'll give up is that this is going to be running in single-threaded mode, so that's one downside. But otherwise, it's still a pretty fast, snappy experience. And once you've run it, you have a few different things that we have built in for seeing your results. So the first thing we have is, will look very familiar to sort of like a Stan summary output. It'll give you your mean, your Monte Carlo standard error, and then also some standard diagnostics like R-hat and ESS for each of your parameters in this first summary tab. You can also just look at, if you want to look at a just raw table of the draws, and you can also download them either as one long form table, or if you want it split by chains like you would get out of Command Stan. The final two tabs are we provide some plots for you just out of the box. So we give you histograms of each parameter. And then also, if you want trace plots for diagnostics, if you're like a big fuzzy caterpillar fan, there you go. So that's already sort of enough that you can teach a pretty basic level tutorial on Stan. But if you want to take it to the next level, we also provide the ability to actually run your own code in either Python or R as part of the UI. And so there's two places you can do this. The first is actually to generate or supply this data.json. So obviously you can just edit it yourself. But if you want to, you can also click over to this data generation tab. And then we give you either the option between Python or R. And you can run code. And as long as it sets this data variable to a supported format, it will update the tab down here. So I'm going to use R just because it loads a tiny bit faster in my experience. But if I click run, it will start loading. And if you look at the JSON real quick, in about hopefully 10 seconds, you'll notice that it'll just sort of update. And there'll be a message that says it updated. And of course, it will choose this time to be slower than it was in my demo. Oh, there we go. So now that it's loaded once, if you look in the data.json and I click, you'll see that it updates. So that's that. You don't just have to, in this case, it is just sort of randomly generating from known parameters. If I quickly switch to the other example we provide, which is a simple SIR model, similar to the one, actually even simpler than the one we heard about earlier. This one actually loads data by installing an R package and then loading the data from that data set. So you can do really sort of, as advanced as your imagination probably in terms of getting the data from the internet or doing whatever you want for loading the data. If I switch back to the linear regression, just because it runs faster, and I go back to sampling, so the compilation server does have a cache. So if it's seen a model before, it's quicker to compile the second time. As you saw, that was much faster. Of course, now it is not letting me click run. Try refreshing the page. This is a good time to note that the things are stored locally, so you can refresh the page and you won't lose stuff. But oh no, why is it not letting me click run? That would be unfortunate. Let me try just not hitting the compiler cache. I also might have to disconnect my Wi-Fi. So the next thing that we do is, besides those pre-provided plots and things, we also let you run Python or R code with the samples in scope as sort of a downstream analysis. And so this can be used basically in Python. We give you an object that lets you get the draws as a NumPy array or an RViz object. And then in R, we actually provide it already in one of the posterior draws formats. And so you can run code from baseplot or posterior and sort of do your own bespoke analysis of your code, which it is not, I didn't account for this. So, oh, there it is. So now we have draws, and now I can click over here. And now if I drag this over, I can quickly run this. So we provide this ability just to generate a quick example code. Obviously, you probably want to write something more interesting than this. But if I run this, it will produce a bunch of text output saying, oh, I installed baseplot, I did all this other stuff. And it'll recreate the histogram of just the LP parameter. So as you can see, it'll tell you a bunch of stuff of, oh, it gives you the summary. And then it also says, oh, I'm installing all these packages. And then eventually, you will get your nice baseplot graphics. So you can use ggplot in Python. Anything that's built on matplotlib will show up in the equivalent panel for the Python tab. And these are all just using existing open source technologies, WebR and Pyodide, that are really great and are really nice for this. Oh, and there we go. So it's a bit, the zoom is a bit difficult to see, but if I make it smaller, you can see that this is, in fact, the LP histogram. So there are a few other features that we think make this really useful for sort of collaboration tutorials. So the first thing to note is that these example links over here are not like magic that's built in. We actually have a way of preparing a link. So it'd be, thank you, stand-playground.flatironinstitute.org, and then / and then there's a few different keys you can put in, like project equals or stand equals with a link. And then that link will pre-populate the fields when you click on it. So if you had a tutorial, you could prepare a set of links and tell the users, all right, now click on link number 1, and it would load the first model. And now click on link number 2, and that sort of thing. The other thing that we let you do is save the project locally, or this also will actually help you prepare those links if you want. So you can click on the Save tab. This is also where you can edit the title up here. So they'll say hi again. And you see that it also updated up here in the top bar. So if you click Save to Zip, you'll get a zip file locally that just contains all the files. So if you want to try to continue running things locally, or you want to email that to someone, like that's an easy way to do it. You also have the ability to save to a GitHub gist, which is like a service provided by GitHub just to sort of put some files together. And if you do that, we'll generate a link for you that will say, hey, you can send this link to anyone. And when they click on it, they'll get a copy of the instance loaded up in Stand Playground. So if that has some extra setup instructions, you need to give us permission to add things to your GitHub account, but that's all explained if you click on that button. And then I'll click Save to Zip just so I have something. And then let me load something totally different. So if I load the other example, I can then click on Load here. And this gives you the option to either provide a zip file that was previously from the Save button, or if you want to just upload like an individual file you've already been editing locally, you can do that. So you can see in the background, there's the disease transmission example. And if I click Load, and I click on that zip file from before, now we've got that back up. And so that is basically the last big feature. Something that I did that I'm very proud of is there's also a dark mode. Yeah. So I'll say you can now feel free to click on it and break it as much as you want. And we really hope that if people use this either for your own personal things, just because you don't want to install Stan on the laptop you're using, or if you're running a tutorial, we'd love to hear feedback. We already have ideas for things we want to take it from here, but we're really excited to hear sort of what everyone uses this for. So thank you. Sure.
Two questions. So great work. Really, it's really like compiling Stan model is such a pain for so many people. I don't get why, but it is. Docker container, do you consider to Dockerize what you've done here, basically? First question, and second one would be BRMS model. I don't want to write my Stan models myself. BRMS does it for me.
Sure. So the backend server already is Dockerized. So anything that can run Docker, you can just run our Docker image, and then you'll have your own local version of the compilation server. BRMS is something that we think is conceptually very easy. So we already have this thing that can assign to this magic data variable. You can imagine something that could just assign to code, and then you could just call BRMS's make Stan code. I think that actually getting that to work will require a bit of sort of engineering effort, but will almost certainly happen eventually. Yeah.
Well, I know this is probably not the point, but how much performance loss compared was it to Ski?
So it's difficult to say. For a lot of these things, we're using for a lot of tutorials, you're using models where they almost run instantly anyway. And it will depend on things like how much else is running on your laptop and stuff. But I think it's only about 20%. It will probably also depend on your browser and stuff. So like I think Firefox is actually slightly slower in its WASM implementation than like Chrome. So that's something that we're curious to hear about. So I should also say that browsers do put a limit on the amount of memory a tab can use. And so if you have a Stan model that has like a gigabyte worth of data in the model, chances are that it will probably not work with this. But like we're still actually, we keep thinking we're going to hit these limits, and then we actually find that they're further away than we think. So we're curious to hear, where it does sort of stop working for people. And that's part of why like we try to make it as easy as possible to download everything and then use it locally if you want to. But, yeah.
Data stays locally.
Huh?
Does data stay locally on your computer?
So the data does, and your Python script and your R scripts and stuff do. To compile the Stan model, it does get sent to a server. So either you run a local, if you don't want it sent to us, you can run a local server or whatever. But so I should note that we don't save anything. There's no there's like a page view counter, but there's no analytics or anything. There's no cookies. It's just like, a local cache of your files and then the Stan. Sure.
Stan Copilot?
So, maybe there are other things so I also maintain the VS Code plugin for Stan. And so like in that, I have things like autocomplete, not intelligent autocomplete, but just like function names and stuff like that. That would be nice to also get into this web version, but that's one of those things that like I've been meaning to do and I just haven't. But I don't think we're going to get a GPT in there yet. Yeah. Sure.
Is there any advantage, you think, over accessibility of, say, Jupyter Notebooks when you're teaching?
So, yeah, so the sort of biggest thing that I've seen people use for this in previous tutorials is things like something like Google Colab. The advantages there will probably be just things like the ability to rely on this existing in the future, right? Because you can, even if we stop providing the public server, you'll always be able to run a server yourself. Whereas Google Colab, I have my own personal doubts about whether or not Google will keep providing free compute forever. But even right now, you still need a Google account, which not everyone will have. And so, I don't know, it's also still just like faster. Like even in the tutorials I've been in that have used Google Colab, there's still like the first instruction is usually the person says something like, all right, everyone open this Google Colab notebook and run the first cell because it needs to spend 15 minutes installing things, right? Whereas this just, is sort of ready to go as soon as you open your browser.
Another drawback from Google Colab that I'll mention is, when you edit a Stan file, it doesn't recognize the syntax. I prefer the panel layout that you have here in RStudio to the notebook layout. That's a personal preference, but I just think it's better for teaching.
Yeah, I think there will still be situations where you prefer one or the other, right? Like if there are instances in Google Colab, I think, where you can use GPUs. So like there will be situations where that will still be valuable, but this is just an alternative.
I just wanted to probably in the future can use web GPU.
Oh, yeah, maybe. Was that a question? Yeah.
Just in comparison to Google Colab, there are now relatively easy ways to run Jupyter directly in the browser. So that might also be an option. If there would be some API you could just expose in some way to compile the models, that might be also nice to kind of just have a way of interfacing this with something, with different front ends.
Yeah, hard maybe. Yeah.
Okay, let's thank our speakers.